Looks like we're right. And so welcome. We've just started the recording and we'll go ahead and get started now. Let me share my screen. And you should be able to see now this presentation. Feel free to interrupt, by the way, with chat. Let me just open that and leave it over here on the side. Feel free to interrupt by unmuting yourself and asking questions. Highly interruptible. I don't have too many slides here. I just want to start a conversation because everybody here has a lot of experience in software development, certainly in web development or in Web 2 development, maybe a little bit, some of you in Web 3, or you're just getting started. So I just want to start a conversation that bridges this gap, between Web 2 and Web 3, and maybe this is interesting for you. But in general, my opinion is this is a fantastic time to get involved in this space. I say this as someone that's been building software since the late 90s. It's been about 25 years for me. My name is Sherif, by the way, and if you're curious, I'm happy to talk more about myself, but let's stay focused on the subject and about the themes that Calyptus has set up for you. So the idea here is that in the last 25 years, that the key lesson that I've learned is that if you can put in just the right amount of effort at the right time, you get a lot of leverage for that effort. So learning about say data modeling, about JavaScript and so on early, say 20 years ago, gave you a massive advantage over the last couple of decades before it became popular. And so now is really a great time to get involved in Web3 and learn about these L1s like Ethereum, Solana, Polkadot, Near, and others. And so, I'm going to give you a couple of ideas about what I've learned, so far, and then we can have a discussion. Again, feel free to interrupt at any time. I want to start with this question about where are we right now. I think this is very useful to keep in mind, especially for folks that have been in the technical space for a while, because it always helps to see the context that we're in. So here, I want to suggest to you that we're at the edge of something new, and I'm presenting to you the whole story here. So we can call 1940s until the present as Web 0, where basically the transistor was invented, networks were connected among military bases, and TCP/IP invented for submarines operating with intermittent connectivity, ARPANET, DARPANET, universities, and so on. Up until today, the connected web, if you look around your desk, maybe you might find 3 or 4 computers which are connected to the internet. And if I said to you, I have this new mobile phone, iPhone 75 or whatever version they're on, and I said to you, it's amazing, and it had the cameras is infinity pixels, and the memory is beyond your imagination, and so on. There's just one small problem. It doesn't connect to the internet, and you can't connect it to the web. What would you think of a device like this? You'd probably laugh and think it's kind of a step backwards. Maybe it's even a brick, you would call it, because most of the value comes from the connectivity of these devices. And then, of course, the high-powered compute and storage that we get in our pocket is good, but the big kind of nut, the big value comes from connectedness. Is there a question in the audience? If not, please mute yourself. So that would, let's say that's Web 0. My intention here is to leave the screen in the slide mode in case anybody's curious. So that's the connected web. The readable web, again, 1960s until the present, I would say, Web 1, we can call it, is everything from what you saw in the very early days of bulletin board systems in the 1980s. And the early experiments, obviously, with connecting these machines and sharing data back and forth. You may have seen the mother of all demos, where they did some connection across a network and shared some data on YouTube or something. So the readable web is this mechanism that allows us to consume data through this pipeline of the connected web. So again, the Web 0 being the connections, Web 1 being the readable web. Today, the sort of readable web is you can ask Siri what the weather's like, and Siri will answer you, or whatever it is. You can keep up with your friend's latest TikTok or something like that. So that is this readable web, this highly available, ever-present kind of ability to consume what's going on. The writable web, that started really with our ability to upload files and then to maybe edit content on the web, GeoCities and things like that in the 90s, up until today. Basically, you can launch a podcast from your mobile phone, or share a TikTok video or what have you. That is really the sort of two-way story with, famously Clay Shirky, the philosopher and technical evangelist, quoted maybe 15, 20 years ago saying, and I think he wrote a book called like Here Comes Everybody, something like that, saying that we would transfer all of this extra time that we had from radio and television as a society and pour it into making content, what came to be called blogs, making video. You see YouTube now accrues 30,000 hours of new content every hour. Even if 99.9% of that content is garbage, arguably it's not, but let's say it is, that's still more than 24 hours of new content every hour that gets uploaded to YouTube. And that's just one of many such channels, some paid, some free. I'm sure you've heard of these different channels. So it's really incredible where we are today. And then Web3, the trusted web, where we can really rely on the sort of irrefutable truth that will be captured in Web3. You would think it's a very recent thing with Bitcoin and Ethereum and so on, but actually a key component to the trusted web really started in 1976 with a paper by Diffie and Hellman around public-private key cryptography, basically sharing secrets in public, and the mechanics of that, and mathematics behind that. And so that's really why it's labeled there as 1970s to present. So then to sum all of this up, you can say it's taken us about 100 years to optimize the movement of data through space. That's a very sort of high-level summary of where we are today. With Web3, we're now talking about irrefutable, mathematically irrefutable identity and a shared passage of time. Bitcoin is white paper, if you take a look, has 8 references. 3 of the 8 references are about decentralized timekeeping, and Bitcoin is essentially called the first decentralized clock, a clock that pays people to keep it ticking, basically. Ethereum, on top of that Bitcoin clock, put a Turing complete machine where you could load custom language into the machine, custom bytecode into the machine, Solidity compiled, and execute that, again, irrefutably on this clock that ticks away. And then all of these new L1s, Solana, Polkadot, Near, and others are basically just optimizing, Avalanche and so on, are just optimizing this Turing complete machine in terms of scalability. We'll see that on the subsequent slide here. And so with this, on top of the idea that you can move data through space, and now we can capture identity in this clock, it gives us the ability to do all sorts of interesting things, like one of you mentioned, decentralized autonomous organizations, where people can essentially vote by signing a transaction with their private key, and that is basically an irrefutable representation of their digital identity. The token economics and mechanism design that you see in all manner of Web3 applications now. And then this, maybe futuristic idea of total disintermediation, civics API, borders API, humans API, who knows where this will go. You can really go deep down the rabbit hole. And you can take a look here. There's a link in this course that we'll be able to share these slides with you. So taking a look at some of these, again, feel free to ask questions along the way. Taking a look here at some of these technologies, Bitcoin brought us cryptographically verifiable transactions and decentralized storage and compute on this public ledger. So it's these 3 ideas, basically, that you can sign a transaction with this public-private key cryptography that makes it cryptographically verifiable. You can decentralize storage and compute, among a network of computers. And you do that because you have this public ledger where the data is secured essentially by the network. The fact that the data is public is a prerequisite of that. There's some work now with something called zero knowledge proofs that allows you to maintain the same security without actually making the data necessarily public, being able to keep those transactions obfuscated in some way, but still being able to verify the compute and the data behind them. Ethereum is basically Bitcoin plus this Turing complete machine, where you track the inputs and the outputs, the code and the data basically on the ledger. And then the problems with both of these, that they're expensive, low throughput, they're hard to scale. And of course, there's innovations with Bitcoin, Lightning Network, with Ethereum, side chains, a number of different mechanisms there that are scaling Ethereum. But Near, Polkadot, Solana, and Avalanche, to take 4 examples of this new generation of layer ones, what they call layer 1 technology, are trying to do this in a different way. Near shards, basically splitting up. I don't know if you can read this very well here, but basically shards the storage and compute. And so, you can have an unlimited number of shards. I think right now Near is running 4 shards. And then the block, the ticking of the clock, is what this horizontal block is. Depending on the block time, you can say, according to the wall clock that you see, on your wristwatch or in the office, this might be like 1 second or something like that every tick. Ethereum ticks every 15 seconds. Bitcoin ticks every 15 minutes. But this would be 1 tick of this clock here in the network, and the same thing for each of these. And then you can split up the transactions of something that might be a little bit more complex. You can split that across multiple shards and get higher throughput. With Polkadot, they have this relay chain and then parachains that merge into the relay chain after processing in parallel, similar to an Ethereum sidechain kind of idea in this picture, but you can also call it sharded if you want. Solana, scaling by timestamping incoming transactions very quickly, tens of thousands of times per second, and then splitting them across multiple pieces of hardware to parallelize the work, and then merging them into a coherent block or tick of the clock based on the timestamp they got. And then Avalanche, splitting transactions by specialization, a C chain, a X chain, a P chain, for different kinds of transactions, basically. So protocol on the P chain, Ethereum-related transactions on the C chain, and so on. So that gives you a sense of how the parallelization is working. But in general, what we're talking about for all of these Web3 applications is easy to understand, or easier, in my view, if you keep in mind the history here that has gone. So we've spent the last 80 years or so optimizing the movement of data through space, and now we're adding from 1976 the ability to maintain a mathematically irrefutable identity by public-private key pair signatures, and the passage of time in these decentralized clocks, which we're now trying to scale through parallelization of the workload, right? The storage and the compute. So hopefully that gives you a kind of a clear sense of what Web3 is, why this matters. If you talk about sort of applications in this technology, I might say to you something like, how do you identify yourself? Who are you? And you might say, oh, my name is John. Okay, prove that to me. How do you prove it? You're going to produce a passport or a driver's license or something like that. And what that is a piece of data that is stored in a database somewhere, a centralized database, with a state or federal government somewhere around the planet. But if it was publicly available data, then you wouldn't need a United States or British or Turkish passport or whatever. You could use any sort of rendering technology, your smartphone app or something, just to show this is the passport data or the driver's license data that's recorded on chain. Now, the problem that comes up immediately is privacy. People would know your details. If it's public, you'd be able to see it. And that's where zero knowledge proofs come that have been theoretical up until the last year or two, and probably in the next decade or so, we'll see these becoming more practical and deployed in the wild. But the idea being, every thing that you own is effectively a timestamp in some database. Your house, your car, any credential you've ever earned from a school or university is basically a timestamp data in some centralized database. So the implications here are massive when you zoom out and think of it in these terms, that we've spent the last 100 years or so, 80 years or so, moving data through space, and now we've added identity and time. So hopefully that point has sunk in. Web3 developers are at an all-time high, so that we're at an inflection point of sorts here. In the last 10 years, this tech is about 12, 13 years old. If you start with Bitcoin, 2008, 2009. And so now we see tens of thousands of monthly active developers, engaging with projects, committing code, thousands of projects, 1 in 5 joining the Ethereum ecosystem, fantastic ecosystem. There are others, don't forget. And as a technologist, I would suggest to you, your best bet is to spread out what you know instead of focusing on just one tech. If you think of, maybe you're familiar with JavaScript and the evolution of the front-end frameworks, you may have picked React and been happy with it, but had you studied several different front-end frameworks a few years ago, you wouldn't have wasted your time with Vue, for example. So it's good to plug into several different L1s to be able to compare and contrast those to have an informed opinion. Maybe you already know that, so I'm preaching to the choir. And so this is from a report that's linked here as well. Feel free to take a look at that. All right, let me just pause there before we dive into the patterns. Any questions, any comments from the audience?
I think just to add, actually, in terms of our timeline, starting with Ethereum, but I mean, Sherif is right. Over time, we're going to be teaching Avalanche, Near, Algorand, other chains. So this becomes a multi-chain ecosystem. Ethereum just being the most adopted right now, but in the future, learning across all different technologies is going to be really important. So yeah, exciting to be launching those in the future.
And if I might add that we have already lots of content on the platform, and Sherif there was talking a bit about cryptography, and that is a very, very important piece of the puzzle for cryptocurrency, and we do have a module built out and a project included in that. So hopefully lots of you will find your way to that module in due course. But yeah, Sherif, really enjoyed that first 15 or 20 minutes. Thank you.
Of course, yeah. Any
Sherif,
comments, questions?
I have a question. So yesterday we had an office hour where I was, interacting with a lot of users of our platform, and some of them had a question about their career regarding the stack that they should learn. So one of the most commonly asked question was that people are learning Solidity as well as Rust, and some of the people are confused whether they should learn Solidity first or Rust. Whether they should learn Solana programming. So we would just like to know your views on that, like learning different stacks, learning different blockchains. Should we focus on that simultaneously, or should we first focus on, one blockchain, say Ethereum, and then move to anything else if you want to learn any additional blockchain? You can answer this later, like after the session as well. So yeah.
No, that's fine. Happy to go ahead. Somebody else speaking?
I think we'd just like to know your views on it.
Yeah, sure. Happy to talk about that a little bit now. I think, again, because folks in the room are fairly senior, that was my impression. I don't think everybody got a chance to introduce themselves. A couple of new folks stepped in since we walked around the room and folks said a couple of words. But just to kind of to give you my perspective on this. In general, when we talk about technology, there's the difference between theory and practice. So you can study, let's say data modeling, for example, with relational databases or whatever, theoretically, and get a sense of how that works theoretically. And then you can get into the practicality of, modeling with a SQLite database or MySQL database or Microsoft SQL Server or Oracle database. And what you'll find is, at the theoretical level, you can really move quickly and play with ideas. When it comes to practice, you then have the sort of, overhead of having to install a compatible, environment in which you can execute commands. That can sometimes be quite difficult depending on the operating system you have or the tools you're using. Sometimes there's expense associated with that. And then as you get into the mechanics of expressing yourself with code, syntax errors can bite you. You can waste a bunch of time troubleshooting things that an expert would know to ignore from the beginning. And that is really the sort of the difficult piece of deciding to learn anything new technically is this sort of distance between the theoretical and the practical, and the tax of practically engaging with technical systems. And not to mention the opportunity cost. You sort of lean into something, you realize a year or two later that it really wasn't the best thing, and you didn't have time to study something else. And so that's a little bit tricky. There's also the question of the motivation behind it. So depending on you as an individual, you might be energized by sort of theoretical constructs and reading about ideas, and you might be exhausted when it comes time to practice. It might be the opposite. You might really not enjoy reading so much about theory, but get incredibly energized by seeing bits and bobs move on the screen and the ability to kind of manipulate proofs of concepts and stuff like that. And so I would argue that's another component that you should think about clearly and carefully, is what gives you energy, what energizes you, what excites you when you're doing this, because that's what's going to help you build the momentum to kind of smash through any of the hurdles that you run into. As we all know, maintenance of code across versions, ecosystem challenges, cultural friction within an ecosystem, especially in open source. You can find things going sideways sometimes. So really find the thing that sort of excites you most and dig after that. You also want to keep in mind the idea of the availability of a body of work. So as a senior developer, one of your strategies, your go-to strategies, is probably to study a large body of work. Maybe you also read books to kind of help you organize the sort of mental models that you need to use. But quite often, just reading someone else's code helps. And it's not just reading one project, but maybe 10 or 100 projects that you really start to pick out pieces that are really interesting for you. And you can sort of rework those pieces and reshape them, especially the pragmatists among you who prefer to get their hands in without the theory so much, or without putting so much time, so much emphasis on the theory. What you really need is a large body of work. So that's another important consideration. And then when you're talking about moving beyond the learning into execution or delivery of a product, you also want to consider the audience at play. So how big is the user base? How easy is it to acquire customers that are already have sort of removed some of the friction of engaging with your product? Basically go-to-market considerations. You can wrap that up into that story, and then on the financial side, you also want to consider, if it's a serious project, if it's not just a hobby, what support there is in the ecosystem, grants and hackathons, prizes, awards, and so on. Who's well funded, who has financial staying power. I forget who to attribute it to, but the idea that something that's been around for a long time is likely to be around for just as long a time. Something that was born yesterday may not survive tomorrow. I forget who to attribute that to, but the idea being that there are these other considerations outside of technology. So then if you put all that together into the question that you asked briefly before, should I study Solidity or Rust, or what should I focus my attention on? I would say that the largest body of work for a senior developer to study is now in the Ethereum ecosystem, and there's no debate about that. If you are looking for tens or hundreds of production examples, code that has been running for years in smart contracts, Ethereum is the community that's going to give you that. Also, they have the largest user base and the largest sort of capitalization in terms of total value locked on chain, in terms of transactions, in terms of new customers onboarded. Any metrics that you want to look at, basically, Ethereum is the 800-pound gorilla. And so that's a good bet to start with Ethereum and with Solidity. And Solidity is a kind of a C++ plus kind of language. So like JavaScript, like Java, it's not going to be strange to you if you're familiar with those languages. There are some kind of idiosyncrasies, some particularities of working with the blockchain that you'll have to get used to. And of course, now, years after Ethereum was launched, and with many production examples, there are all sorts of listicles you can find online that explain top 10 mistakes I made when I was building my first smart contract, things like that. That's going to really save you a lot of time. So that helps with the opportunity cost question. So Ethereum's a good bet, and Solidity is a good bet because of that. But keep in mind that Solidity is a bespoke language, a custom language designed to target the Ethereum virtual machine. And so it's not sort of arguably it's not standards based in the sense that it is sort of specific to Ethereum. There's nobody else outside of the Ethereum ecosystem that depends on Solidity. And so, versions can change quickly and sort of the semantics might change and things like that. So you might want to, consider that when you're dealing with this. When you look at the layer ones that are using Rust, there are many. If you learn Solidity, you'll be able to program for Ethereum, for Avalanche, for a number of these systems. But Rust opens up another group. So Solana, Near, Polkadot are all using Rust. And Rust is a standards-based language developed at Mozilla that is basically C++ without all the footguns. And so if that statement doesn't make sense to you, let me put it this way, developers of C++, if anybody here has used C++ in production environments, a lot of what the developer has to maintain in their mind, that is potential gotchas, the kinds of bugs that creep into programs, freeing up memory twice, or allocating some memory after it's been freed. There's a bunch of these patterns that happen in C++ programs that are basically managed by the developer as they are crafting the program, are now explicit in the language with Rust. So in Rust, you can't make those mistakes. There's an entire class of mistakes that C++ developers have been struggling with and cursing for decades that are just eliminated by using Rust. There's a trade-off there. It means that when you're beginning your journey as a Rust developer, it's like chewing on glass. You basically wake up in the morning, you grab a handful of glass, you throw it in your face, and you just chew on it all day long, and it sucks because the borrow checker is unforgiving, and Rust in general is not an easy language to learn unless you already know C++ or Go, for example. Strongly typed language like that will make it easier to transition to Rust. But if you're coming from JavaScript, you just prepare yourself for some weeks of suffering, but it's worth it at the end, because what you end up with is a language that forces you to think much more clearly about what you're doing and much more explicitly about what you're doing. And so essentially, once the program compiles, it basically works and you don't need to worry about it. And it's those safety guarantees that makes Rust a fantastic choice for this decentralized, clock that is ticking away and should never crash, basically. And so it makes it much less likely that a program would run kind of amok, or that you would have some bug or something in the program of a certain class of mistakes, right? And so that's the benefit of Rust. It's standards based, a huge community. It's one of the most loved languages on the planet for several years running now. You can see the Stack Overflow developer report. So Rust is a good bet as well. But when you're deploying, to some of these L1s, you may not find so many users as you would find in Ethereum. So again, you want to consider that. What are you building for? Why are you building? So if it, I guess maybe to kind of put this, speech into a box and tie it up here, we can say, if you're looking to launch in the next couple of weeks or a couple of months, and you know exactly what you want to do, and you just want to get the biggest sort of splash in the market, then probably Ethereum is the right move to make technically and from a business perspective. If you're just getting started, and this is something that you intend, an industry intend to break into over the next, say, 6 months, 12 months, or something like that, then Rust is probably a good bet, if not exclusively, at least as a kind of another thing that you're thinking about while you're learning Solidity. So hopefully that answers your question.
Yes, very detailed indeed.
Any other questions or comments? Anything else we want to discuss?
Guys, feel free to type in your questions in the chat box, if any, like even while Sherif is presenting, we can discuss it towards the end as well.
Yeah, exactly. No problem at all. Let me just keep going. So when we talk about smart contracts, let's just take the mystery out of these things. A blockchain is basically a slow, expensive database. And it's fine. You can think about it like a slow, expensive database for the first, couple of months that you're working with blockchain. It's really not a problem. The big sort of idea is that it's a slow, expensive database that doesn't lie about anything. In fact, it can't lie. You can't lie. Nobody can lie or modify the truth that is captured on chain. And what a smart contract is basically a piece of code that's executing on this database, stored procedure if you want. And you call it through some external interface like an API. In fact, there are APIs. You can execute a method, you can maybe assign a transaction, you can upload some data. It depends on what the API exposes to you. So with a smart contract, what you have is this piece of code that is running in a Turing-complete machine, and you can do things with that from the outside, like invoke a function, pass in some parameters, get some result, things like that. So hopefully that gives you a sense of what a smart contract is. And it's really just that. There's not much else to it. Every L1, every one of these layer 1 technologies that I mentioned here, Ethereum, Near, Polkadot, Solana, Avalanche, and so on, have their own definition of what the smart contract interface is, what the language is, what the API is. but in general, when you're talking about using designing an application that includes Web3 technology, you can think of, I had this application, and part of the application, I want to guarantee that whatever is written there will remain, forever. And maybe it's, something like a library of, books that we've shared or something like that. I want to make sure that the connection between the title of the book, or the ISBN of the book or whatever, and the person who shared it can never be changed. But I don't care so much about who checked the book out, their review of the book, how much they liked it, who else they shared it with, what their notes were. So what I can do is split off the part of the application in terms of my application architecture, the part that I don't want to lie about, I want to guarantee will never be altered. I can split that off from the part that I just could use a traditional database for. So in this particular application, this library or whatever, I might store, some kind of hash of the book title or ISBN or whatever, URL that represents the book, URI that represents the book, and then connect that with maybe the identity of the user according to some on-chain identity or a public key or some other sort of artifact they've cryptographically signed. And then that way I have this pairing that shows that these people, uploaded these books or shared these books. But then maybe in a MySQL database over here on the side, I can share things like the comments people are leaving, how many likes they had, how many downloads they had. And then my interface would merge those, the front end or whatever, would merge those into some useful user experience. So that's where these pieces fit in. Any part of the application that you want to guarantee behaves in a very specific way as coded by the developer, as uploaded to the chain. Of course, you should make these smart contracts open source, and so people can go and read the code and see what's executing on the blockchain. But it doesn't have to be the entire application in that smart contract, just to be clear. And so what patterns do we see in these smart contracts and in these applications? Here are 4 kind of categories, and then I have here some breakdown of each of these, so we can discuss those in turn, and feel free to interrupt with questions. So you have patterns of constraint, let's say, with the smart contract. So that these patterns are patterns that emerge from the rules and limitations that are enforced by the system. And we can dig into those. So just to give an example, patterns of constraining identity is like a method in a smart contract that can only be called by a specific account, you see, or maybe the contract can only call itself, right? So that would be a pattern of constraint, somehow constraining the way that the system works, okay? Patterns of creation, maybe patterns about how the contract is created or destroyed. And so in that sense, you might notice some of these words here from design patterns. If any of you are familiar with that, the Gang of 4 and what that looks like, so factory and builder. But there are other kinds of patterns here that are you can find in smart contracts. Patterns of communication, how contracts communicate with the outside world and so on. You may have heard of oracles. This idea that basically you have some way to get to information off the blockchain, and so we can talk briefly about that. And then patterns of storage and what that looks like here. So different kinds of storage that you might imagine are there. So that's the four kind of patterns that I hope to kind of get into your head today, and then talk about a couple of these things as we move along. Again, if you have any questions, feel free to interrupt. Just a time check here, Calyptus team. It's 45 after the hour. I think we've got about 15 minutes left, right?
Yeah, I mean, last time we ran over by 5 minutes or so. Obviously, if people have to jump off at that point, absolutely fine. But yeah, if we run over a few minutes, that's not a problem.
Okay, nice. Yeah, that's fine. I can wrap this up in about 5-10 minutes, or I can go for much longer, just depending on what people want to hear about. So let's talk about these patterns of constraining things, because this might be interesting for some of you. So imagine that you can write an application that only allows me, Sherif, to call a specific function, maybe an administrative function or something like that. And in a typical Web 2 application, how would you do that? You would maybe hard code into the application that this particular user account, user ID, is the only one that is allowed to do something. Whatever my username is, admin or something like that, and that admin identity past some security barrier of the application depends on the integrity of that security barrier. So like a username password combination, maybe you've got two-factor authentication, maybe you're using OAuth, whatever it is, but there's some sort of wall coming from the outside that's over here. Once I pass through the wall, I'm now known as admin inside of your application. And the problem is, of course, that there are ways to get around this wall. There are ways to socially engineer the password away from people. There's ways to sort of break down the wall or have the application break in such a way that you can kind of subvert the wall, whatever I'm talking about, just different ways of getting through these typical sort of mechanisms of identity that we have. With a blockchain application, when you say identity, what you're really talking about is a public-private key pair match. And so if nobody has my private key, if I just as a rule make sure I never share my private key, then it's basically mathematically impossible to forge this identity. And so the blockchain will maintain that because your identity can only be verified by confirming that the public-private key pair match with your identity. You sign a transaction to call a function, let's say. And so the idea of constraining a method call or constraining the use of an application by an identity takes kind of a whole other meaning there that is more foolproof, basically. So unless you have my private key, or I don't know, you come to my house with a wrench and extract my private key, you're not going to get it. And so that's the idea. All right. So here, number. So for example, constraining that something has to be limited to some number, like the number of fungible tokens or the number of NFTs in a collection or whatever it is. Again, you'll find these kinds of constraints are very common on chain. And because of the way the blockchain is sort of maintaining truth, there is nobody that can kind of come into the database and edit a record somewhere and say the number is now this other thing. It just doesn't happen because what you have in the blockchain is this clock. All of these technologies, Ethereum, Polkadot, Solana, Avalanche, Near, whatever it is, Bitcoin, they are all essentially a clock that ticks with a series of changes that are being applied to the state of the blockchain. So you can't sort of go in and change it later. It's impossible to do that, mathematically impossible to do that. Constraints of time, where you can track time on the blockchain. Remember, when your code executes, sort of the mental model to have on the blockchain is the clock is ticking, whatever it is, the Ethereum sort of clock is rolling over, or the near clock is rolling over. And in this tick, your program wakes up when it's when some interface is called, function is called or something like that. Your program wakes up and the code executes, line by line, and you can reach out in that moment and ask the execution environment, the runtime, for information about what's going on. Like, what block is this? What Unix timestamp are we at? Who just called me? What is my name? For example, or my address. So you can get those things from the context in which the code is running, and then you have some limit, and then you can you have to shut down basically. So that's the idea. And so time is one of those things. Certainly uniqueness, with regards to like NFTs, you can make sure that a record is unique. If you're curious, what is an NFT? A lot of people ask this. What is an NFT? The easiest way I found to explain this, again, if you just keep in mind that we're talking about a slow, expensive database, an NFT, if you open a spreadsheet right now, Excel or Google Docs or whatever your spreadsheet of choice is, and you just type into a row, maybe like row number 1, you type your name, and maybe in row number 2, or column number 2, excuse me, you type, whatever it is, monkey wearing, shiny sunglasses, whatever. And then in column 3, you can put like an image of that monkey. That is an NFT. It's uniquely identified with the row number. It has your name, some identity that is in the owner column, let's say. We can put a header if we want to in the first row, I suppose. An owner column, it has the NFT, say, metadata beginning in column 3 and onward. You can add whatever other metadata you want. The price of this thing, how many times it's been traded, where it was minted. There in the spreadsheet, there's an unlimited number of columns. So with an NFT, you're basically buying this row in a spreadsheet. The big deal is that the spreadsheet is controlled by God, or if you find that word a bit weird, it's controlled by this slow, expensive database that doesn't lie. And so the idea is that once you buy it, it's yours and nobody else can own it. And you say, well, what if someone takes that URL and puts it into a different contract and just kind of basically copies all the pictures? Sure, they can own that picture in a different contract, but it depends now on sort of verifiability. Is this the original Mona Lisa or a perfect copy of the Mona Lisa? The original Mona Lisa is, depending on the conspiracy theories you follow, is a sort of well understood, painting that lives in the Louvre in Paris. And it doesn't have any copies of it. And so there's just one of those. It's the same as your spreadsheet row, the NFT. Any copies might look a lot like the Mona Lisa, but they're not the Mona Lisa. That's just one thing that exists in this one smart contract that is managing these NFTs. So if that helps kind of make sense of some of this stuff. Personally, I'm not a fan of NFTs, but I am a fan of fractionalized ownership, for example. So if I own a car, and I need to take out a loan, let's say, to fix the car because, I don't know, something's wrong with whatever, the wheels, and I don't have that money, I might be able to fractionalize the car into, let's say, 1,000, pieces, shares of my car, you might say, and then sell those on a marketplace where people can buy them for, $10 or $100 or whatever, up to some value of the car that I'm trying to finance. And then those people have those, those sort of IOUs on the car. If I sell the car in some, a secondary market or whatever to my friend Bob, and he gives me some money, then you would be my creditors, the people who own those tokens. You'd be my creditors. I'd have to pay you first, let's say, because there's some law that says I have to do that. So there's some missing infrastructure still, state or federal legislation to support fractionalization of a home or apartment or a car or some other hard asset. But that's an interesting idea. A driver's license or a passport as an NFT is an interesting idea. But I'm not a big fan of like the pictures of like monkeys and stuff. I think that's kind of weird. It doesn't matter. Maybe you have one, good for you. So membership would be something else. So imagine like that you are a member of a club or that you know a club of people who are allowed to drive in this country. That would be like a driver's license, right? So you could have a membership, or people who are allowed to travel, you know, with a sort of a record of your membership of being, say, a citizen of this country. That would be called a passport. So you can have things like that, and a few other patterns here. So I don't know if any of these are interesting for you, or maybe some are more interesting than others. If you have any questions, you want me to focus on any of these things, please let me know. I have a question here from Ankit. Is it possible to create an NFT of an existing picture which is not in digital form, like the Mona Lisa? Yeah, I mean, going back to the metaphor, Ankit, on a spreadsheet, forget about blockchain for a minute. If I said to you, is it possible to create some representation of the great works of art, you know, of a particular artist or a particular period of time in a spreadsheet? You would think, yeah, of course. I mean, what's the big deal? I can do that today. Probably there's some chat GPT command that I can use to generate a table of like famous works of art that's in CSV format that I can just import into a spreadsheet. And so it's just that easy. Once you have some digital representation of the thing, then you can encode that as an NFT, because all an NFT is whatever that URI is, that universal identifier, whatever, however you're going to get to that thing that you're claiming is unique, and then the owner, those things are connected somehow on chain. The idea being that the owner is attached to a digital signature that can't be, it's irrefutable, mathematically irrefutable, and the unique identifier only appears in that one location, Mona Lisa or whatever it is. So you would have to have some digital representation of Mona Lisa. Maybe it's some digitized picture of whoever the proper legal owner is of the Mona Lisa in the Louvre, standing next to it with the piece of paper and thumbs up or something saying this is yours, and then you hash that and put that on chain. Whatever it is, you need to have something that goes onto the blockchain so that you can reconcile that connection between the identity and the thing that you're trying to own. So there has to be some digital representation at some point to put that into this slow, expensive database. But anything you can do that with. And I think there was a couple of articles that came out about people that did these wild stunts where they created an NFT on chain and then they burned the original in public, in some grand ceremony or whatever for the paparazzi to enjoy with their with their attention vacuum. And just basically talking about how exciting it was to sort of take something out of the real world and put it into the digital world. That seems more like a stunt than anything else. But as long as you can digitize some representation, then you can call it an NFT of the Mona Lisa. Someone had a comment, maybe?
Ankit, if you just explore Damien Hirst, the artist, he's a famous British artist, and he did a product called The Currency. This is what Sherif's talking about. He made 10,000 real life artworks, just made up of dots, polka dots, lots of colors, and his army of creators who made these 10,000 pieces for him. And then he sold those pieces, real life pieces. No, sorry, he sold the NFT version of them, so photos of them, to 10,000 people. And then he said, after a year, I'm going to give you an ultimatum. Either you, as the purchaser, are going to keep that NFT, or I'm going to swap it with you for the original copy. But either way, one or the other will be burnt. And so actually the experiment was, it was about 52% of people took the artwork and 48% of people took the NFT. But yeah, it was a very interesting public experiment, but definitely worth looking at.
Yeah, that's great. I hadn't heard that before. There's a few of these stories. I was thinking about some other item in the newspaper, but that's a great one. Damien Hirst, you said? If you could write that into the chat, that would be great. The name, so people can look that up in case they didn't catch the spelling. That's quite interesting. Yeah, look, for sure, it's 2022 right now. We're almost at the end of this year. It's been a very strange time globally. And for the last couple of years, we're coming into this kind of this decade with all sorts of new patterns of work and life and travel and so on. For sure, blockchain has characteristically has been all about the hype for this last year or two. DeFi is an interesting development, but I think that people are getting a little bit too creative sometimes with the DeFi scene. NFTs, shiny things, people love shiny things. If you go back 20, 25 years ago and you look at the beginning of this kind of personal computer, internet story, certainly in the 80s as well, but I'm talking specifically about this internet world, there were a lot of shiny things that people were talking about 20, 25 years ago. And then sort of everything, kind of the hype died down. People spent a couple of years doing some serious work. And then 2003, 4, 5, we saw kind of the beginning of what we now know as the kind of the social web and Web 2.0. But there was really a lot of noise for a few years there, I can tell you, from mid-90s up. So here we are in that noisy phase. I personally hope this bear market is going to quiet that noise for a year or so. It's a perfect time to get in as a developer and start learning about this stuff and building. Because as this comes back, I can give you as much assurance as I can as someone with 25 years experience in technology. This is real, this technology, whatever the company is or the community or the details are. This slow, expensive database that doesn't lie is not going away. It's a new part of the way that we manage data on the critical path that is sort of has the highest level of guarantee, the guarantee of mathematics, basically, that nobody on the planet has the resources to lie about the data here. Thanks so much for being here, Vasily. So to go back to Shashank's next question, fractionalizing real, or comment maybe, fractionalizing real estate would be a great idea. Brought me into Web3 world, developing a platform, a real estate agency that does this, helps them raise funding. Yeah, amazing, Shashank. That's good to hear that it's happening. Of course, with when we talk about, I was watching this series recently about capitalism and the machinery of capitalism. A lot of what makes capitalism work is the law, actually, the ability to reconcile dispute, the ability to claim sort of ownership over something, to enforce that ownership in a court of law or in a sort of settlement outside of court. It's quite common, actually, depending on the jurisdiction and the nature of the grievance. So a lot of this has to do with adoption by this cast of lawyers, essentially, internationally, who will help to sort of literally spell out the details of reconciliation around fractionalization of various assets and what that means. And but it's coming. I mean, I'm quite confident of that. I have very high confidence that this tech is here to stay. The question is, what applications will we see that actually capture the public's imagination and take off? So thanks for sharing that, Daniel and Kaylin. Yeah, so we're talking about, and then Calyptus HQ is asking about views on CBDCs and threats and benefits associated with it. I'm not really qualified to talk about this, but I mean, I can tell you from what little I understand, it makes sense that in a global setting where the role of the central banks has been to effectively manage the temperature of the economy and to sort of reconcile differences among nations and to broker asymmetry in the relationships of power across nation states. These are big ideas here. It's very unlikely that you and I are just going to kind of get to trade in NFTs and tokens and fractionalize ownership of our various assets without someone else getting their hand involved. And so CBDCs, are these central bank digital currencies, are certainly the sensible move for the establishment to come in and say, here is the new form of money. Don't worry about cash anymore. Everybody should be using the CBDCs. It confers a ton of benefits, traceability, verifiability, throttling. You can imagine, for example, some people talk about these questions of sort of the environment and how we can sort of manage environmental crisis at a localized level. It's possible, some people theorize, that with a CBDC, you could only have the ability to spend your money within a 15-mile radius of your registered address, for example. Once you leave that radius, your money doesn't work, or there's a discount on your money. Maybe it's like worth 80 cents on the dollar or whatever. So some of that stuff is a bit far out there. Obviously, policies like that would need a lot of work to get any kind of support. But the idea of cash as a means of sort of moving value around at the individual level has a lot of benefits. And so it remains to be seen kind of where that stuff goes. Matt H says, and that's maybe that's more than I know about what CBDCs are. So I don't know if that's useful for you. Matt H says the gas fees on Ethereum are becoming cost prohibitive to participation. Yeah, so do you think this will be addressed before or after mass adoption, better alternatives? Look, gas fees are, generally they I think people's impression when they first hear about these gas fees, they're like a little bit offended. They're like, I've been using the internet for free for all this time. The cost of a access provider or a cell phone plan, and I can just browse and consume and post. And so what's the point of these gas fees? Like, who gets that money? What's going on? And the idea of these gas fees is actually quite simple. The fees are used to secure the network. What does that mean? Well, those fees, predominantly, depending on the mechanics of the chain, are either going to deflate the currency because they get burned in some networks, and so that maintains the value of the currency, or it goes directly to fund the miners or validators that are processing the transactions of the network, essentially keeping this clock ticking. They don't do that out of the goodness of their heart. They do it because it's a viable source of income. They get paid to keep the clock ticking, check the transactions, compare them, communicate about the results they got once they process transactions, to make sure that the clock is ticking in a way that the transitions, state transitions are coherent, that they're verifiable, that they're correct, and so on. And so that's where that goes. It depends on the network, depends on the protocol, about what actually happens with those fees. Sometimes they go to pay people to do that. Sometimes they get burned. Sometimes they accrue to the contract developer themselves, maybe to create another source of potential income there, and sustainability for those applications. So again, it depends on the details, but that's what the fees are about. They're very high on Ethereum. Some people argue they will trend towards being very high no matter what the network, because that's just the nature of this technology. Other people argue it depends on the implementation, actually, but there are some layer ones out there with hundreds or thousands times cheaper gas fees than Ethereum. So totally worth checking those out. Without mentioning any particular names, do your own research. But basically, I would argue you should go and check out every one that I've mentioned here. So Bitcoin, Ethereum, Near, Polkadot, Solana, and Avalanche. Go check all of those out and build something for yourself on each one of those, something small to understand how they work on their test nets or whatever. Hopefully that'll help. So thanks for asking, Matt. Somanat is saying property is presented by an NFT. It's fractionalized into multiple X NFTs. Yeah. Can those X number of NFTs be out on a rental market for a timeshare lock-based renting? First NFT is not broken into ERC20 tokens because they can't be rented with a timeshare lock-based system. How do you solve the problem of renting fractional assets? So, again, Somanat, I don't know if now is the right time to try and do this. I'm also probably not qualified to do this, but let me take a shot at this at a high level. When you're talking about anything you want to do, let's talk about this pencil concretely. I own this pencil, 100%. It's in my possession. You don't own it, I own it. But let's say that I set up a robot here that allows people to remotely use this pencil. It's still mine. Nobody else can use it, but it's possible if I allowed them to. And then I set up a mechanism where you could buy some fractional ownership of the pencil or whatever, and $1 bought you a day of use, 24 hours that you could break up into increments as small as 1 second of using the pencil or whatever. And the machinery is all set up so that you're only writing on your part of the world or whatever. I don't know. The analogy is breaking down a little bit. Then what we do with this pencil and the rental of the time and the ownership and fractionalization, what that means is not limited by the technology. Remember, we're talking about programmable money, and in a Turing complete environment, basically, you can simulate any machine, you can simulate any system. So your imagination is really the limit. Talk about some of these folks, the folks who came up with Mindstorms and Scratch, out of MIT. Folks like Alan Kay talking about computers being like tools of the mind, or Steve Jobs is famously quoted as saying computers like a bicycle for the mind. The idea being like whatever you can imagine, you can code into these systems. So I could conceivably sell you something, call it an NFT or a whatever, LMNOP, ABC, it doesn't matter what you call it. I could sell you something which allows you within the constraints of this system to control this pencil for some period of time. And the agreement is determined by and tracked by the code, the state and logic of that system. And there could also be a component where if this pencil were to be sold, let's say, that you would earn, whatever, value you get from that. So there's no constraint on sort of problem of renting fractionalized assets or fractional assets in my world view of how this stuff works. It's just something that you have to define into the system. So I don't know if that's helpful or not, but Shashank says NFT is an escrow smart contract, and in exchange it creates ERC20 token, the amount you can decide when the ERC20 comes together, when the NFT can be realized from the escrow. Until then, it's an escrow smart contract. So, again, I'm not sure, Shashank, if you're replying to Samanth or you're talking about something different here, but just to kind of add some context for folks who are reading this, when you talk about NFT, this non-fungible token, it's this row in the spreadsheet where every row is unique. You have an owner in one column and then any arbitrary metadata in the other columns. That's good enough as a mental model for an NFT. It's not a spreadsheet, it's a code in a smart contract, some data structure that you're building in there, whatever, an array or a map or something. It doesn't matter, but the mental model of a spreadsheet is good enough. And then when you say ERC20, that's just another standard. So NFT is a ERC 721, I think, and the ERC is a Ethereum request for change, or I'm not sure what that stands for, ERC. But it's basically a proposal mechanism where if you look this up, you'll find in GitHub, the issue number is the number that gets incremented in this centralized database in GitHub of issues basically that they post as they make these proposals to change. And then you get ERC20, ERC 721, whatever they are. There's a bunch of these ERCs, by the way. ERC 721 is more commonly known as NFT, non-fungible token, but it's basically a standard that defines an interface for a contract with a bunch of methods that you use as part of an NFT so that marketplaces and other things wallets can like list these things and interact with them in a standardized way. ERC20 is just another standard that talks about a fungible token. So it's again a set of methods or whatever for wallets and marketplaces to be able to react with fungible tokens like Doge, you may have heard of that, coin, that kind of thing. And so I think Shashank is playing with these ideas about an NFT in this smart contract, escrow meaning the contract holds it on your behalf, maybe, and then it exchanges some fungible tokens. You can take some and do something with that, maybe. I'm not sure if you want to explain that a little bit more clearly, but that's basically the ideas that I'm talking about. So
yeah. Sherif, you're right. So actually, this was the idea, like having the NFT in a like escrow smart contract where it like holds the NFT and gives the ERC20 token in exchange of that. And
sure,
when
yeah.
the amount of token, the amount of token it gives, if it comes all together, then the NFT can be released. Like I've read like open source code like that. Like some marketplace are using like this like their
Yeah.
code was.
Yeah, that
have
makes
gone.
sense, Shashank. I think, I mean, so
Yeah.
you're basically, again, in terms of the details here, we're talking about sort of, these are all programmable mechanisms. So without getting into any particular
Yeah.
implementations or marketplaces, what I'm trying to share with folks on the call or folks watching the recording is sort of the mental model that will allow you to join the conversation. So NFT, row in a spreadsheet. ERC20 or fungible token, you can think of it as another spreadsheet that has one column with the owner name, and then the second column is just how many of these things you have. You have one of them, 100 of them, 10,000 of them. How many of these tokens, Doge coins, say, do you own next to your name? And as you trade them, sell them, whatever, burn them, that number can change, can go up and down. But those numbers are managed by the smart contract. So that's the difference between NFT being basically owner with metadata of the token, versus a fungible token, FT, let's say, is the owner and the numeral value. How many of these things do you actually have, right? That's basically a reasonable mental model for those two standards.
Yeah.
And of course, the standard also defines a set of methods on a contract, and you can extend that. You can turn some of those methods off by not implementing them, for example, or throwing an error if you like. It's just software in the end. You're just programming. So thanks for sharing, Shashank. So Matt is saying Pink Tata is a membership-based primary secondary market for hotel rooms, architected on tokenization. Yeah, tokenized hotel reservations. Fantastic. Yeah, there's a lot of these examples. And this actually might be something interesting for developers to collect. I don't know if Calyptus has some kind of repository of like examples that devs can look at in the wild, various applications and the way they work, for example. But
Like
there's all sorts of.
Alchemy I just wanted. Yeah. Sorry.
No, go ahead.
Like I just wanted to add, Alchemy just like published this DApp store, like a website where they have the collection of dApps, all the dApps, like all the in the ecosystem. So they have like categorized and they have made subcategories.
Yeah, it's
so
quite
Alchemy
common.
just launched DApp store.
It's quite common that they have these collections of these of the applications. So you can go and find sort of how many applications are are available. Like, for example, if we go to Solidity by example, let's say if you search Solidity by example, here you'll find a bunch of these examples, right? Some of them are kind of small constructs like this. Some of them are maybe a little bit bigger sort of pieces, and even full applications that you can find, implementations or whatever, right? So this is quite interesting, right? So here's open source, decentralized finance, DeFi here, where you can do things like borrowing, lending, staking, yield farming, all that sort of stuff. And in the end, it's basically just playing with these various constructs that we're talking about here. So this is an example. I'm also familiar with like Awesome Near, this website that has like 1,000 projects on Near. So there's a lot of these things that you'll find categorized and structured like that. They have them out there. So I would encourage you to go and look for them because it's quite useful to see what else have people built. One of the problems is a lot of times when you're looking at it from the outside, it's hard to understand what the model is. You really have to invest a lot of your time and energy reading through the documentation, white paper, whatever, to try and figure out what actually is the essence of what the thing is doing. And so that can be a little bit frustrating sometimes, but there are still some applications out there that are quite simple to understand. Well, I can't quite remember them right now, but if Calyptus does have some place where people put links like this for everybody to see, I think it would be great to add to that and build out a curated list for developers to come in and just quickly see, oh, yeah, this is cool. Here's an example of, whatever. And go and look at the source code and see how that application
I think
works.
it's a really good recommendation. So of all these, going through Solidity by example, we cover off all of these headings and they have examples to all of them. And then we have a bunch of different coding projects, but to have a repo of just kind of various examples would be actually really interesting for us. So we can start building that. And from next week, we're going to have all of our employers who are hiring from Calyptus, putting up all of their GitHubs. So everything that they're doing from a very top level is going to be open source. So even companies like Superfluid, which you may have seen last week, all on GitHub, and everything's going to be there, so you guys can explore the companies as well on the platform.
Well, that's amazing. Yeah, I mean, there really is so much going on right now. It's a perfect time to get involved. I think safely for the next few months, maybe a year or so, before the market starts picking up again, you have an advantage actually of getting involved and learning about this tech right now and throughout the first half of 2023, let's say, or all of 2023. You have an advantage because a lot of people are kind of pushing away from this technology right now, all the hype and whatever, and I don't want any piece of that. It's all a bunch of Ponzi schemes and all that. So that's fine. The tech is real. And so you can dig into that now and get a head start. That would be my recommendation. Is now's the time to double down on learning the tech. Don't worry so much about the news hype cycle. Focus instead on how this thing works actually, and see if you can get to it. Okay, so we're about 20 minutes over. I think maybe it's a good place to stop there. What do you guys think?
Well, thank you, Sherif.
Yeah.